All right. Welcome, everyone. Good morning, good afternoon, good evening, wherever you are. Thanks for joining us. And as we get going here, we'll say hi to you. Welcome to the Traceable AI API webinar series. Today's webinar is on mobile API testing. My name is Dan Gordon, and I lead the technical evangelism team here at Traceable AI, and I'm happy to be your host today. We've got some great knowledge to share with you, but before we do, a couple housekeeping items. Today's session is being recorded and will be available to you afterwards through the BrightTalk platform. It's also going to be linked from our website in the resources section. Second, we welcome questions. In the webinar control panel, you should see a Q&A button. If you enter your questions in there, we'll do our best to answer those towards the end of the session. I'm proud to be able to introduce once again today's speaker, Dr. Katie Paxton-Fear. Katie has her doctorate in insider threat investigation using natural language processing. She's a cybersecurity lecturer, a white hat hacker, and a YouTuber teaching about API security and ethical API hacking, which you can find on her channel, Insider PhD. So we're honored to have Dr. Katie Paxton-Fear with us today. Thanks for joining us. With that, we'll turn it over to you, Katie.
Thank you, Dan. Before we get started here, I'm just going to apologize in advance. The UK is currently suffering a heat wave, and it's 30 degrees, which I understand is about like 86 degrees Fahrenheit. However, we do not have air conditioning in the UK, nor buildings are made of brick. We have like insulation. It's really humid because we're on an island. It's very hot here. And because I don't have any of these measures, there's currently like an amber warning for disruption because of the heat. My laptop is like 70 degrees Celsius. It's hot. I'm really sorry in advance if, say, my internet cuts out, if my power goes out, etc. If I do drop off, don't worry. There will be a recorded version of this talk that I will be recording when it's not the hottest part of the day here.
Yeah, I think we calculated it's like inside your house, it's over 100 degrees right now, right?
Yeah.
So thank you for sweating it out for us.
It's awful. But yeah, so just don't worry if I drop out. If that's the case, this talk will still be available.
Yeah, we'll finish the recording and make it available. Sorry.
Let's talk about what you've actually come here to listen to, not the weather forecast, which is mobile API testing. So in our previous kind of discussions on these webinars, I've talked a lot about web APIs, and they are APIs that are usually exposed for, desktop or, laptops or kind of desktop applications. And that gives us, in terms of like being penetration testers, that gives us so much power where you can easily have proxies running. We can easily inspect the API's traffic. We can perform reconnaissance using command line tools. We've got a lot of power at our fingertips when we're using kind of traditional web APIs. Of course, nowadays, most APIs aren't actually served to traditional like computers because we all have tiny little computers in our pockets. Most APIs are not actually served over, traditional kind of desktop applications, but instead you're on your phone. And there's very good reasons why that's the case. It consumes less data if you're using something like, mobile data. It allows you to use the same interface for both a web version and mobile version. It allows you to build it once and then just kind of do front end stuff. It saves on development time. There's a lot of really good reasons why APIs are particularly useful for mobile apps. And in fact, as we kind of go onwards, we're now seeing, IoT devices. As IoT devices become more and more popular, we're again seeing those far more commonly use those APIs than we see like traditional desktop use. And with that, that's obviously quite a big security risk, because as great as it is that we have tiny little computers in our pockets and, we have a toaster that can give us the apparent perfect temperature for toast, or we have, webcams that we can access wherever we are in the world, and we can have Ring doorbells or what have you. They're actually much more difficult to test. And what that means is that they often get shipped insecure. And there are a lot of flaws in mobile APIs that you just don't see as commonly in something that's a bit more well tested. So what are we going to do? Well, this week, I'm going to tell you all how to get started with mobile API testing, what makes it the same as desktop APIs, what makes it different from desktop APIs, and how you can get started right now. So why hack mobile APIs? APIs are really, really common, particularly when we start to look at, mobile, IoT, wearables, all these different locations. It means that processing happens off of the device, and developers assume most phones will have internet. Because unless you're like me, who lives in like what seems to be an internet black hole, most people do get internet through mobile data. And with that, not only is that the case, but even if you're like traveling, people assume you'll have access to the internet. Now, they can be the same as you have in a desktop application. There's very much an idea of develop once, like develop that one API and use it everywhere. But often they actually aren't. And there's like loads of different reasons. Some mobile specific things is a concept called batching. So if you assume that, okay, the device will likely have internet most of the time, however, it may not have internet all the time. So when you do have internet, if you batch all the like API requests and then get all the responses back, you can kind of do an update really easily. So that's one reason. There are some mobile-specific API design patterns. So design patterns are ways of building applications for certain like necessary requirements that if someone else has done it before, just copy them. The other reason is developer specialities. Now, a few years ago, there was quite a big push to have like universal applications, which is actually, I think, dying down a lot. There still is a lot of a push for it, especially if you live in the OS X world. It's still very common. But for something like Android, we're not really seeing the same push that we saw for the universal Windows development platform a few years ago. And with that, it means that the people creating, iPhone apps, Android apps, desktop applications, websites, regular web APIs, they're often different programming skills and require different skill sets. So what does that mean? Well, oftentimes, mobile apps end up being this kind of we'll just build out a proof of concept using like on desktop first, and then we'll build the mobile app later. And that is like slowly changing. It tends to be more that people build for mobile first. However, it's definitely the case there's still this like people don't necessarily think about both when they look at developing APIs. And that means that APIs can sometimes even be mobile only, because a web application might be built by a different team in a different country, led by different people who aren't talking to the mobile team, that have different types of programmers with different skill sets. So with this, my kind of recommendation is if you're watching all these API hacking resources and you're like, okay, yeah, I really want to give this a go. This sounds very exciting. I really want to have a go at this. If you can't really find an API you want to test against, because let's say, you're looking on something like a bug bounty platform where it's legal to do this, look at mobile apps, because oftentimes companies will have the mobile apps in scope that they use, and that will often have an API associated with it. Off the top of my head, Verizon has, I think, the entire catalog of Yahoo apps on the App Store and scope on their program, for example. So what's the general approach to hacking APIs? Well, if we look through all of the other webinars I've done, step one is find endpoints. So the first thing we try and do is we try and collect as much as possible. That's when we talked about in the API recon video. We were like, okay, how much of this can I find? Like, how much of the attack surface can I find exposed? Step 2 is to link that attack surface to that business logic, that high-end features. In the API testing methodology, this is something I mentioned. I mentioned part of my methodology is always not to just be thinking of an API in terms of requests and responses, but really start to link that back to that high-level business logic, high-level features, and actual functionality that people use. Because it's all well and good looking at a bunch of requests and going, oh yeah, that does that, that does that, that does that. But it's quite a different thing to think about how a user then looks at that, because they don't see the individual request. They see those kind of big pieces of functionality. And for a lot of API-specific vulnerabilities, that can be really important, because rarely do we test APIs in like this little bubble of, oh, that's the API testing. Often it kind of overlaps with more traditional web pen testing. Sometimes it does have API-specific bugs, or sometimes the vulnerabilities you end up finding are a mixture of both. Now, 3 is really the sign of the usual suspects. I mentioned in one of my first videos, the way I kind of approach API hacking is this kind of what I'm looking for. If I see a large response, I'm immediately thinking about information disclosure, information exposure. You know, if I see a really large response, but not that much on the API, is the kind of like front end there performing some filtering between the two? Is there another request happening? How is that actually working? And that kind of sets my mind off. You know, if I see I'll give an example of like an actual app I pen tested, where I essentially had this app was like for games. And what you could do on this was when you got points in game, you could redeem it for things. And most of the games were kind of like mini quizzes. Think like Kahoot, think like, you know, those kind of like Q&A things, trivia, that kind of thing. So when it sent you all the trivia questions, it sent you, you know, what you'd expect to find on the API. So the question, the answers, a true or false Boolean about which one was the right answer. And, you know, that's maybe not a huge information disclosure. But immediately when I see that kind of large response, I'm like, okay, so as soon as I click, you know, I want to do a quiz, I get all of the questions, I get all of the answers, and I also get which answer is correct. And with this, the more of these points you got, you actually could end up redeeming that for like different currencies and like in-game items and stuff like that. So what I was able to do is then, you know, write a very quick tool that could abuse that information disclosure, and then also on top of that, do a more traditional kind of business logic, which ended up being kind of closer to what you'd expect in something like web pen testing, and return back this like getting these free items. If I see IDs, I'm immediately thinking IDORs. Some of the most common vulnerabilities, they occur when a resource in an API doesn't check that you own or have permission to do something to that resource before letting you do it. So, you know, think about if you account ID 3 and there's an API endpoint that's like delete account, you send it an ID of 3, it should go, you're asking to delete account 3, you are account 3, therefore it will be deleted. So as soon as I see an ID, I'm always checking for IDORs or BOLAs, or broken function level authorization in some cases. You know, as soon as I see authentication required, I confirm it. You know, I don't just take it that, you know, this is where it kind of also ends up kind of crossing over to traditional pen tests, web app pen testing as well. If I see a registration, a login, reset password, like I'm always going to test those as well. If it says that I need an account, well, I'm going to confirm that I do in fact need my own account and I can't just use somebody else's. And what I then do is like, you know, go through those endpoints, go through those high level features, one at a time and start testing them. Now, this is something that when you first get started out with any API hacking or pen testing, this takes time. And this is fundamentally what makes API hacking quite difficult. It's not technically that challenging, especially there's a lot of bugs that don't require technical expertise, but you have a lot to get through. APIs expose really large attack surfaces most of the time, so it can take a while to get through all of that. And that is the general approach to hacking APIs. I've just summarized, how many have I done now? 4 webinars. So I've just summarized 4 hours for you in 10 minutes. But that really is just the surface. This is a very general approach. And if you want more information on how you do each part of those, I really do recommend that you watch some of the other videos in this series, all available on demand. Some of them have demos associated with them, because I think you'll get a lot out of them, more so than this very quick overview. So how do we get started with mobile? Well, step 1 is that we need a phone. And there's 2 ways of doing this. So I'm first going to talk about iOS. So I do iOS pen testing the most, and weirdly enough, it's because it's a little bit easier. Now, for doing iOS pen testing, what you need is a physical iOS device. Now, I have an iPad mini 4. So it's the previous generation or the generation before. It was before they had support for the Apple Pencil. iPad mini, which is great because it's halfway between an iPad and a phone. But it was cheap. So I really recommend, if you want to get into iOS specifically, go on Facebook Marketplace. Those kind of areas, you can pick up iOS devices for actually quite cheap. And especially if you go for the kind of iPad 4, iPhone 8, they're also all vulnerable to checkra1n. So checkra1n is a jailbreak. Basically what that is, if you're not familiar with the idea of jailbreaking, is it bypasses some of the security controls on an iOS device, which allows you to do things like sideload applications, make tweaks to the underlying packages actually on the device. SSH access has a bunch of really useful features. Now, if you do this, you're going to need to do something called installing SSL bypass. And what that means is it will completely remove any SSL pinning. So if you do go this route with iOS, and I must stress this, you shouldn't use your iPad, your iPhone, whatever you tend to go with, for regular things without switching it off. Jailbreaking by default makes your device insecure. And sometimes that's fine if it's not in your threat model, it's not in your threat model. But really worth, just making sure that you know what you're doing in terms of what if you end up using your own personal device. In addition, there can sometimes be a risk of bricking it. Very unlikely nowadays, but it's the case. You're more likely just have the jailbreak fail and have to do it more than once. So that's iOS. On the Android side, you can use a physical device. Now on Android, if you use a physical device, you're going to need to root it. And this is very similar to jailbreaking. As you might imagine, Android has a root account, and rooting is exposing the root account. Again, it exposes quite a lot of the operating system. Mobile devices are quite locked down in ways that computers aren't. And what that means is that you basically just need to bypass these security controls. Now, with Android, if you choose to use a physical device, there's a little bit more work you're going to have to do with it, but we'll talk about that in a second. But again, you need to install something that's going to bypass the SSL cert pinning, so certificate pinning. And again, it makes sure apps on your phone insecure by default. So really do make sure you know what you're doing if you tend to use your own physical device. Now, if you don't want to do that, you've got a good solution. So on Android, it's really easy to have access to Android emulators. I really like Genymotion because the default devices work really well. And on top of that, it's not super laggy. Sometimes they can be quite laggy. And you can do things like access the Google App Store, which makes it easier to sideload applications. Now, if you want to have an emulator for iOS, you can. Little bit more challenging, so I'm not going to go too much into that. But that's essentially your 2 options. I really like iOS testing. People like Android testing. Another benefit of Android over iOS is that you can do the difference between like static analysis, looking at the APKs, and dynamic analysis, which is more how you do API testing. It gives you a bit more options. If you would like any more information on sort of getting a lab environment set up, I have these 2 videos. But to briefly kind of go through it, for iOS, you will need a physical device. You then need to jailbreak it. I recommend checkra1n. You can also go to can I jailbreak, and it will, can I jailbreak, and it will tell you based on your device what jailbreak you need. You download something called SSL bypass, and you're ready to go. You just need to then proxy your traffic through Burp or whatever web proxy you use and install the root certificate. Android, if you use Genymotion, you install Genymotion, pick the version of Android you want, install the root certificate, proxy it through Burp or whatever web proxy you want to use. And, I've kind of summarized it there because it's not really like in scope for this talk, but there are like these full 20-minute videos with like guides that kind of go through all the stages, and you can follow along with them. So another thing that's kind of really useful is something called Freeda. Now, this is really common for mobile hacking, like in general. So basically the way it works, it's called a dynamic instrumentation toolkit. You can basically write scripts that will like run as the application runs. And this is kind of like really boring, but it can do really useful things. So classic example, the ability to tell when an API request is using HTML, when the HTML is rendered, whether or not you can perform more traditional injection vulnerabilities there. On the API security top 10, but using something like Freeda makes it really easy to identify those potential injection points. You don't really need it for iOS or Android testing, really, but it can be useful for a few things. So is the app rendering JavaScript? And is what's actually being called in like things like web views? Sorry, I'm losing my train of thought here. Very hot. But it's really easy to install. So Space Raccoon has this great guide on how to get started on iOS, which goes over installing Freeda. Completely out of scope, but useful to know that it exists. And it's definitely something, if you decide you want to go into it more, that something you should know about. So what do we actually need? Well, the same as we need for any other API testing. I did tell you there was like some differences and some similarities. The same as like every other demo we've done. We need a way to view the requests and responses to and from the mobile app. I use Burp. You can use Zap. You can use Postman. You can use an emulator, a physical device. This was going to be part of a demo, but I use an iPad Mini 4 and Burp. It's personal preference. The same personal preference you probably already have from the other talks. So it really isn't like, don't think about this as like, oh, it's so much different to what I'm used to with all the other things. It's really not. It's really just a different tool. The actual like methodology is the same. So let's talk about mobile app APIs, because I said there's some similarities and some differences. The similarities is how we the similarities are how we actually test them. There's nothing different there. The methodology is the same. The like tools are the same apart from the emulator or the physical device. The differences are sometimes with the actual way mobile app APIs tend to be designed and created versus their desktop counterparts. So API types, just like the web, there are different types of APIs. Now, what you don't find in mobile apps are things like SOAP or even XML. As they tend to be those kind of older API designs, you just don't find them in apps because JSON and restful was already such a standard when we kind of first started to have mobile devices that they really did take hold. Most restful, GraphQL is becoming more and more popular. I've definitely seen it more now than even like a few months ago, definitely becoming more popular. The main difference between the two is that a RESTful API has many different endpoints. A GraphQL API has one endpoint and loads of different queries you can run on that single one. Now, what you kind of find very commonly on mobile apps is actually custom APIs that don't map to a specific type. Because mobile APIs tend to be written in-house and often written by mobile teams, that can mean that what you might think is like traditional kind of API design conventions just aren't necessarily the same on mobile apps, which can make it quite difficult to hack. There's quite a big challenge there of like, how do you read like this one team's really specific way of doing things, right? And that tends to be the major difference. Now, what's JSON? If I just said it, but what does it actually mean? Well, if you've seen any of the other talks, you probably know. JSON is this format here. It's these curly brackets, these two dots, the quotation marks, the commas, etc. So JSON is the usual format that particularly mobile APIs return. It's a way of taking data from a database or a piece of code and turning it into text that we can then transmit. It's machine friendly, and it also means that like all your phone is sending and receiving are very small pieces of data in comparison to like XML, which has a slightly larger overhead, not that much. But in terms of something like a picture or a video, the difference is huge. Now you can recognize it because it has this very distinctive format of curly braces. What it's showing here is key value pairs. So employee is the key, Max Musterman is the value. And it essentially lets two systems communicate using text, but also still be readable to a human. That is fundamentally what we're looking at here. So what about RESTful? So a RESTful API, so RESTful stands for Representational State Transfer, which used to mean something, but doesn't really mean that anymore because of what like state means in computer science. And it essentially means that each resource has a number of URLs which support different HTTP requests. We have get, post, put, and delete. And then we have a resource name. So get movies, get a list of every movie, get movie, and then an ID gives you a specific movie by its ID. And these really relate to CRUD functionality: create, read, update, delete. They're really highly structured and very easy to spot. One benefit, especially for pen testers, which is also both a benefit and a drawback, is that it's predictable. You have to know the resource names. And when we talked about like API recon, I went into detail about how you actually do this because that's quite difficult to do, especially because while they are designed to be read by machines, they're also designed to be read by humans, which leaves them in this really weird spot of like a hybrid between readable by a human versus readable by a machine. And GraphQL, another type of API. So instead of RESTful, where we have, these different HTTP verbs, and then we have the different endpoints. So we end up for each resource, we end up exposing 5 endpoints. GraphQL, we expose 1, and we write these queries. They're not necessarily like SQL, but they're kind of this structured format. A little bit more complex to retrieve the data from, but doesn't require you to know resource names, and that's really, really important. So other API weirdness. So I mentioned batching. Now, because of the way mobile like apps are just used, we don't know when you might have internet 1 minute and no internet the next. So you might see something called batching implemented. And what this means, as you can see on the side here, is that actually this one API is making a request to V1 checkout orders and also V1 checkout orders, but with slightly different data here. So we have one API endpoint which handles more API requests on our behalf. Now this changes slightly like how you hack. As you can kind of imagine, we're like writing a request to do a request. in JSON. But actually doesn't change the approach. And I really want to stress this, that this doesn't actually change how you approach API hacking. It just changes how you interact with the API. You'll usually interact through the batching rather than through the endpoints directly, although certainly in when this is done well, you should be able to access it then as well. So what I mentioned before is that in like mobile apps, we often see custom APIs. Now, when we have mobile apps where there's no web API, we tend to find these more custom endpoints where actually, we maybe have the CRUD resources that have that really predictable, nice style, but we might also have these weird ones. There's not a clear defined structure like there is for RESTful APIs. Don't panic. Just because you can't do like that kind of more formal recon methodology I talked about in my previous webinar, doesn't mean you can't hack it. Don't rely on automation if this is the case. Look at the features you can actually see. Go into the hamburger menu, go into the settings. If you change the settings, is that just on the app? Or is that actually being sent to the database somewhere? Is that being reflected somewhere? Change your username, change your password. What does that change? Don't just focus on the kind of automated approaches. While really useful, you can actually get a lot from just clicking the buttons and thinking, okay, so this app does X, Y, and Z. So let's try that out and let's try and do things weirdly. Like, let's take an example of an app I think at this point everyone's used, Uber. Now, it's very unlikely on Uber you're going to change your name. However, when you're testing an API, you should absolutely test changing your name. You might think the obvious one there is, okay, I'm going to order an Uber, and then we'll see what request it makes. What happens when the ride gets accepted? Well, what happens if the ride gets cancelled? Focus on hacking the features you can see, rather than trying to map a custom API to a RESTful framework. So I said earlier that RESTful APIs, they are the most common API type to find. They have this clearly defined structure which relates to CRUD, which makes it hard to hack, but not impossible. Now, one thing I really like is this API recon method that Tom Nom Nom did. There's a great talk on YouTube where he essentially looks through JavaScript to find likely resource names and tries to see whether or not that could be likely endpoints. And the benefit here is that structure. Structure makes the endpoints predictable. And that makes it predictable for developers, yeah, and that makes their job easier. But that makes it more predictable for us as well. And that's what we want to see. I did mention in one of my previous talks that we tend to see these kind of not standard RESTful. So we might see a post to a resource name /ID. We might see a post to resource name /ID/delete. You don't actually find that so much in mobile app APIs. We tend to find put and delete. Now, the reason why we find them more commonly in web is because web browsers don't do update and delete HTTP requests very easily. Something like Postman will do them, but the actual web browser, it's not very easy to do. So most people don't bother and just use get and post. However, the same way Postman can make those requests really easily, so can your phone. So you will see that far more predictable structure, and that kind of, when you do see RESTful, it's that classic RESTful, not where someone's had to hack it together. So GraphQL, mentioned this before, but it's definitely a rarer API type, becoming a lot more common in mobile. And actually, this is like a future but past talks I've done on GraphQL. And this is much easier to hack, even on mobile. So there is a function of GraphQL called introspection. And what that means is that allows you to query attributes about the data itself, the queries and the mutations. Now, while that's not a bug on its own, it makes it so much easier because you don't have to predict what the endpoints will be. The API will just tell you. So not only can it return data about the data it's dealing with, it can return data about itself, and that makes it so powerful for both developers as well as testers. If it's not working, don't panic. Again, focus on that functionality aspect. APIs at the end of the day were built by humans and are completely understandable by humans. It does take a little bit longer. It takes some practice, but by just clicking the buttons, you can make a reasonable facsimile of how traditional API recon might be done. So how do you know when you got a GraphQL API? Well, first you'll only see that one endpoint. What you tend to find is references to mutations and queries. So queries query the database and send you data back. And mutations mutate the data you've got and then often return the data back as well. So whenever you see a reference to mutation when you're testing stuff, that should be, your go-to, oh yeah, that's a GraphQL endpoint. Now, some of the cool things about GraphQL testing is once you see a GraphQL endpoint in something like Burp, you can run something called InQL scanner. And what that will do is InQL will launch this IDE for the API, even though the API is on your phone, which just makes it so much easier to write these queries. You can do them on a keyboard, and you're not trying to sit there passing things into if you see like spaces, you're not having a bunch of pluses in there, for example. To be fair, when I think about it, a lot of mobile app versus traditional desktop apps is just click every button. The nice thing about APIs is that they're actually used in the code. Very rarely, especially in mobile, do we see API endpoints that don't go anywhere at all. Usually they go somewhere. They might be deprecated, yes, but they go somewhere. So a lot of what you can do in terms of that reconnaissance is just click every button, try every feature, click every button, find the flow that users are likely to go through and the flow that they're not likely to go through. Hit the hamburger menu, see whether or not the changes in the menus are reflected onto the web server if it's just client side. As much as I've done an entire hour webinar here all about API reconnaissance techniques, sometimes recon can just be boiled down to just press all the buttons. And particularly in mobile apps where and IoT as well in some cases where we have these greater limitations, a lot of the time all we can do is say, what happens when I click turn the IoT enabled light on? What if I turn it off? What changes? What is my phone doing to communicate? Is that, Bluetooth? Is that Wi-Fi? What's actually happening there? So where should you focus your efforts? And one thing that's really worth pointing out is that when we do penetration testing, but especially bug bounty hunting, we want to look at impact. So we want to focus on either where impact will be high if it's hacked. So payment systems, logon, authentication, authorization, those functionalities where it's really easy to make a case of, hey, your API is broken. Or where you can bypass the website's protections. Now, people seem to think that hackers live on desktop computers and therefore the only thing they know how to use is the desktop. And so people install things like web application firewalls. Well, if your web application firewall is not also on your API directly, it's not going to work for your mobile apps. So elements that may be shared between web and mobile, always check for injections. SQL injection, XSS in particular, really useful. Oh, code injection as well. Always worth checking for. Go through the API security top 10. So mobile API vulnerabilities and how do you actually find them? Well, what are the vulnerabilities? I can't stress this enough, exactly the same as on web. Like I said, sometimes these are like two very different situations. Often the times, the vulnerabilities are exactly the same. No one expects you to be hacking on the mobile app, so there's actually quite a lot of low-hanging fruit on specifically mobile. But okay, that's probably not what you want to hear. You probably don't want to hear me say again, you should watch this other webinar I did. What are the most common vulnerabilities? Broken user level authorization. So your kind of broken user? Yeah, your bowler, right? So IDOR, bowler, the API isn't checking you own a resource before you can do something to it. Keep an eye out for any ID, particularly in RESTful APIs. If you see an endpoint with an ID, try removing all the cookies, or in mobile land bearer tokens, and seeing if it still works. If it does, if it doesn't work, you could also try replacing the cookies or bearer token with those of another user and seeing if it still works. More difficult to test on mobile, especially when you have one device. However, good way of doing things is getting an Android and an iOS thing set up so you can see it. Excessive data exposure, super common in mobile APIs. An API is just returning too much information when it doesn't need to. And that info can be a security risk, for example, contains PII. Particularly, and I really like how the API security top 10 puts this, is that filtering may only be implemented on the client side. And that's so true of mobile APIs in particular, where a lot of the filtering is in the actual like Java or Swift or Objective-C code. If you ever see an endpoint that returns a lot of information, like more than you think it should, always worth investigating. Press buttons. Hit endpoints you wouldn't normally see. If you see a lot of information being returned, ask yourself, is that a risk? Like, what is that data? Am I seeing that as a user? If I'm not seeing this as a user, why not? Broken function level authorization. Same thing we talked about before. So what we might think is a permission IDOR, you can do an admin action even though you're a regular level user. Really common on like enterprise web applications. In the mobile domain, we find them a lot in community-driven applications. So think things like social media, right? If you're a moderator, you should be able to maybe remove posts. Maybe you'll be able to turn off comments if it's not like Facebook. But you shouldn't be able to do that if you're a regular user on somebody else's post. Maybe you can do that on your own. Any complex permission hierarchy, always worth checking for. Anytime you see IDs, also worth checking for. On web, you can use containers in Firefox. My favorite way of doing things in kind of mobile land is to have both Android as on Genymotion and my like iOS testing and compare it. More difficult to do for sure. Mass assignment. So mass assignment basically means that the API is accepting additional parameters unintentionally along with the intentional ones. So if you've got an endpoint where you can change your name, you probably shouldn't also be able to change your password. Or, you know, maybe you can edit the description of something, but you can't edit the title, those kinds of things. They're more common when APIs end up being built on a framework. It's a little bit more rarer, particularly in mobile land. But it's always worth, like, if you see, especially in RESTful APIs, if you get a resource and you're getting like 5 pieces of data back, then you should check to see whether or not you can then do a put request with those 5 pieces of data. You can also use other tools. One great thing is that you don't always have to be proxying through your device. You can actually run tools against a mobile API beyond the scope of this, but all the stuff we talked about in the API Recon webinar will work here. Easiest way to do it is to just do a get and then check for a put and whether or not you should be able to actually change those. Now, if you want more information on vulnerabilities, most vulnerabilities that affect other APIs affect mobile APIs as well. So I went through all of these in detail. This was like a super quick overview to mainly talk about the risk of mobile in particular. API testing methodology goes into this in a lot of detail. Here's the link. It's this one here. But that is a great one. And then API Recon is also really, really useful too, because again, it goes into more detail on using all of the tools. Now, one thing that's worth pointing out and really stressing, I think, is that mobile APIs can often be used as a bypass. My way of always saying this is like, oh, it's that one neat trick that everybody hates. A lot of the time, filters will only exist on the desktop application side, either in JavaScript or sometimes just the API will go into the database directly without going through any backend code. Sometimes it can be that the mobile API, people don't expect you to be able to render JavaScript. And so they don't think about the risk of something like cross-site scripting in your like iOS app. And my favorite one here is sometimes a fix is only deployed to a desktop application, but not a mobile app. So always test it twice. If it exists in both, you can usually say that they have the same backend code. It's not always obvious. So whenever I'm doing like a test, I will double check on both. I also always retest my bugs, like all the time, retest it, see if it still works. And the same advice I gave last time about different versions of APIs applies here as well. So how does it work? Well, essentially, your API and your website will use the same data source. However, the website backend may have some filtering on it. So if you put it into the mobile application, it ends up going into that database where it can then be executed on the website. I hope that makes sense. It's a bit confusing. But I hope that's a visual representation of what's going on. So hacking different types of apps. So often targets with mobile apps will be different to desktop, which makes sense, right? Like you won't find WordPress installed on a mobile app. You'll often see a lot of social media, banking, transport. You see it a lot. And you'll also see less known vulnerabilities and CVEs because they tend to not be using those kind of things like WordPress where they're using someone else's code. They can exist, and certainly there are ones physically on the devices themselves, but you need to know a bit more about how an application was built, and that often requires going into something like Freeda. So HackerOne actually publishes the most common vulnerabilities by industry. So if you're looking at mobile and you go, oh, I'm looking at, I don't know, a healthcare app because it's like an IoT thing that connects to a pacemaker, or it's something that allows me to transfer my data between hospitals, or it's a COVID application where all the APIs are full of vulnerabilities for some reason. You can see, the most common, thing in transportation is cross-site scripting, so I'll test for that. Always worth looking at these kind of big vulnerability matrices, even if you're on the defensive side, just to make sure you're using like informed threat models. And I really do want to stress this as we're coming to the end of the webinar here, that it's not different from regular APIs. Mobile APIs are not special. They're often built in the same way. They're not tested as often because of the difficulty of getting that initial setup. So they are full of bugs. And when you start to add IoT into the mix as well, and you start to like look at how your like IoT devices are all connected up to your mobile apps, which is connected up to the rest of the internet, like you add all that up together and it's so much of like untested waters here. So this was going to be where I did my demo of API hacking, but unfortunately I couldn't get that to work because stuff keeps overheating and taking forever to learn. So I would like to thank you very much for listening to me. Here are my socials if you'd like to follow me. I'm on Twitter, I'm on LinkedIn, and I'm on YouTube. You could Google me and find all the stuff there. Thank you very much for Traceable, who have kindly invited me to speak, and you can find out more about their stuff with the QR code with your phone. You can scan the QR code.
You can type in the URL too.
Yeah, or you can type in the URL. True.
Thank you, Katie. That was fantastic. Yeah, so we do have, we're going to move to the Q&A portion of this in just a minute. So great information as always. I do want to point out to everyone, all of our viewers, we hope that this detail will help security leaders and developers and everyone viewing here to better understand the risks that your APIs can pose if they're not created and secured correctly. And that's why we want this information out there. Now, usually we like to talk about, just to bring up, and Katie's used to me asking this question if it doesn't come up during the talk, which is, cool, you showed me all these great tools and gave me all this great information. I'm super excited to get going and like try some stuff out, try doing a little hacking. How do you avoid getting in trouble? And Katie, I'm going to ask you that question, but twist a little bit or add a little extra on, which is, we're talking about mobile. So like thank you. So if I pull down the, the APK and pull it off my phone rather, and I start doing all that on my own, are there any considerations I need to have there with regards to staying out of trouble as well? So certainly from the server side, but also what about the mobile?
Yeah. So actually, there's quite an interesting thing you bring up there. Now, not exactly for mobile, sometimes, but something that's a threat in IoT and mobile that's not so much in kind of more traditional web app pen testing. It's actually, there's not just kind of traditional hacking legislation. So it's not just your Computer Misuse Act, the Computer Fraud and Abuse Act. It is also the Digital Millennium Copyright Act, because intentionally bypassing copy protected features can actually get you in trouble under a whole new act. So this is particularly true for reverse engineering, and that tends to be where people get burned. Reverse engineering like IoT devices. However, when you start messing with like APKs, really keep that in mind that there is a completely new act that then comes into play, which isn't necessarily a consideration. I will say, if you hack with permission, either because it's your own, like, not as in it's your own IoT device, it is your own piece of software. It is a software you're conducting a penetration test and you've got kind of a defined scope. Or it is a piece of software that you are testing as part of something like a bug bounty program, completely legal, you have permission. When it comes to reverse engineering and that side of things, just keep in mind, intentionally bypassing copy protection should be a concern. It should be on your mind. Not usually relevant for most things, but just keep it in mind and just realize, hang on, if you're not sure, consult an attorney. My normal advice is, if you have permission, legally it's fine. Don't start testing apps unless you have, if you do start testing apps without permission, make sure you can afford to hire an attorney, a lawyer, a solicitor, because that's when you start to get in trouble. But of course, security research is a thing. It's just something to be aware of, not necessarily something that, you do this, you're always going to get in trouble. Not usually the case.
Or I think bug bounty programs also kind of help with that, right?
Yeah, for sure. Like
being able to communicate and know that you're in a safe place and that you can do
as
what
long
you're
as you
doing.
follow the rules, fundamentally follow the rules, it's not a problem. And in fact, if you're then looking at, especially in the healthcare space, where quite a lot of apps are created by the government, for example, like the COVID apps, they might be part of a vulnerability disclosure program run by the government. For example, in the UK, the National Cybersecurity Centre will do it. In quite a lot of EU countries, the government will allow you to report vulnerabilities as part of a disclosure program. It's also worth talking about with mobile in particular.
Definitely. Thanks. Great information there. Is there a difference when testing iOS and Android APIs, and which one is your favorite?
So I really like iOS. I think iOS has that little barrier to entry more, which is that you need a physical device. But it's actually, in my experience, easier and more reliable to get started with. Like, I know that if I set up my iPad correctly, it's always going to work. I have a lot of problems with Android, just because, like, Android is, I don't actually have an Android phone, so that adds like an extra layer of difficulty. So I always have to use an emulator, and there's a performance concern there because emulation is quite performance intensive. I'm running tools again. In terms of like whether or not there's a difference to the API testing part, absolutely not. It is the exact same. When we then start to look at like Freeda, that does change because it's how the code is written in instrumentation. But when we look at the APIs, exactly the same. Like, there is nothing special about Android or iOS. It is preference.
So addendum to that, then I guess you mentioned about pulling APKs off of the Android phones and being able to pick them apart. Is there an equivalent of that for iOS?
So yeah, iOS has IPAs, but the way they're packaged is a bit different. Like, you can for both, but really, Freeda is the best way to do it and do it while it's running. And like, I could go on forever about Freeda because there's so many different things. By the way, if you're on Android and need to bypass the SSL, there are literally Freeda scripts that will do that for you for whatever APK you give it. There are other scripts that will check for things like web views. There's other scripts that will just see what classes are being loaded from Swift or through Java. So you start to go that route. Definitely Freeda is the way to go first before you start like decompiling apps and trying to reverse engineer them.
Here's one. What's an interesting mobile bug that you found? Let's say most interesting mobile bug.
The quiz was pretty funny because it's less because I think that was a really interesting bug and more because I found it within the first 5 minutes of looking at this application. I was just having a poke around and I was like, oh, it sent me the questions. Oh, it sent me all the answers. And which one is the correct one? Like, it probably took me 5 minutes to find that. And then actually to then write an exploit was like, ended up being trivial because it's like, well, I'll just write a quick script that can abuse this, take a bunch of quizzes, and then redeem all these points for zero work. Huh? Yeah, it was super easy. So that's got to be one of my favorite API bugs, just because like every other one, it's taken a really long time. But that one was so quick that it's got to be my favorite.
It sounds like too easy and a direct physical payoff too, right?
Yeah, exactly. And you could get Amazon gift cards and everything. It was like, if I didn't tell them about it, it'd be free money. But I'm a good hacker, so I told them about it.
I'm sure they appreciated that. All right, great. This concludes the webinar. Thank you very much, Katie, for joining us once again and for all this great information that you shared. Thank you, everyone in the audience, for joining us, and we hope you'll join us soon again. With that, have a great rest of your day or evening.
Bye, everybody.
Bye, everyone.